Hello, this is Mike at Gamefromscratch, and welcome to a quick introduction to the Cycles renderer for Blender. Now, Cycles has been around for a couple of years now. It's been developed in parallel to Blender, but now, about a year back, maybe longer, they integrated it into the main trunk. So now Blender has two renderers built in. The default renderer, called traditionally Blender Renderer, and Cycles Renderer. Now, Cycles is a node-based graph shader approach to things. So if you've done any work at all in Max Maya, Unreal Engine, or Unity on the shader graphs, you're probably already familiar with the concept. Same way as if you've done any GLSL or HLSL programming, you know what we're doing here. It's the same basic concept. You build your textures and image properties up with a network of nodes that feed together. There's inputs and there's outputs, and the rest is the sky's the limit, basically. Now, there's a couple advantages to this approach. First off, you can express a lot more than the built-in renderer allowed you to do. You're capable of creating very, very powerful image results. Also, it can take advantage of GPU-based hardware. So you can have CUDA processing. You can spin it off to your GPU to handle things. On the other hand, though, if you're using Blender just for creating assets, so you're creating animations, models, textured models, etc. for export out to a game engine, don't use Cycles. It's probably going to screw up your export process. It's not for you. This is just for if you're creating still frames, rendered animations, that kind of stuff. So let's jump right on in. First things first, let me back up. What you want to make sure you do is run that whole takes advantage of the GPU thing is critical. You have to have a good GPU to make this work. If you're working with an integrated processor, Cycles is going to be very slow for you, and you're probably better off using the inbuilt renderer. So if you do have a GPU and you're on a laptop like I am with Optimus, make sure that your GPU is being used. So here's a default object in the scene. I'm going to quickly UV map it. So mesh, UV unwrap. And we'll just do a cube projection on that because it's a cube. If this is beyond you, don't worry. Go through Gamefromscratch channel. I've got all kinds of coverage on Blender that can get you up to speed with everything you need to know to this point. So let's look at the traditional materials applied to a shape. So you come in here, there's a material tab right here, and you'll see it's got a bunch of properties predefined. Things like a diffuse shader, a specular shader, shading properties such as light emission, ambience, translucency, you've got a transparency options, etc. So it's got a bunch of settings kind of pre-configured, and you kind of mix and choose what you use, and there's a bunch of stuff there potentially you don't use at all. And then on top, when you come over to the textures category, you also see there's a default texture for you, and here's where you come in and set, I want an image texture or a noise texture or environment map or whatever applied to this. And this has been the traditional way of using Blender for the last decade plus. Shaders changes us all. So let's switch on back to our material tab, and we'll see what happens when we enable Cycles. First off, enabling Cycles doesn't matter if you come up to this top guy right here and just select Cycles Renderer, like so. And now it's on. And what you'll see here is it all went away. There are no default values at all when you're dealing with Cycles. And what you have to do is build your own graph of nodes that create the end result. So you see this magic button right here, use nodes, that's what starts the whole process off. Before I continue, I'll go and show you the textures tab, nothing there as well. So let's head on back here and we'll click use nodes. And now what it's done is created a diffuse BSDF shader. Now what you may be asking is a BSDF. It stands for bidirectional scattering distribution function, and basically it's a math geek giving an artist way too much information. You don't need to know that the mathematical calculation for your surface is using BSDF. It's completely pointless. I don't know why they give you that information. So this BSDF part, ignore it. It doesn't really matter to 99% of us. It just kind of confuses aspects. It should just be a diffuse shader. It makes a lot more sense, a lot easier for us to grok. So let's now open up the node editor. You may have never used this guy before. Hasn't been a lot of purpose before now. So pop open, node editor. And here you can see there is a default shader graph. So all you have here, you have the calculations and the output. And then your output from a shader, again, if you've done GLSL programming, this probably makes sense to you, like you have fragment or vertex shaders as your output. Here you have material output or lamp output, and that's it. So the only two possible endpoints for shaders are material output and lamp output, and you need to have at least one. And now you'll notice there's connections. So on the left-hand side, those are the inputs. On the right-hand side, those are the outputs, and they're color-coded to show you what can feed what. So you see here, green goes to green. Now you've got these gray. Grays generally represent a 0 to 1 normalized value, and then here you've got this mauve or purple color, which I think generally is a vector. So you type that can be input and output. It's easily color coded, and this is kind of as simple as it gets. Like, let's go here. We'll change this guy over to rendered mode. So, and let's show some of the effects. So we can sit here right away and just change the color, and you'll see the result. Very simple shader. Now let's look at something like a little bit more real world. But before we do, I want to point out this whole guy here, this editor, uses very traditional Blender controls. So scroll wheel in and out, middle mouse button pan, B for box select, S for scale, G for grab, etc. You don't want to get rid of something, use the X key, etc. So all of the hotkeys and commands you already know carry over in working in the node editor here. So let's just move that renderer down a bit. And let's take this guy and turn it into a traditional texture map approach. So we've got our output shader, our diffuse shader, or basically color shader. You can come in here, go add another one, and go to texture. We're going to image texture map, like so. So if I come back here, I have a pair of textures that we're going to be using. We've got crate, and then a normal map for the crate. This represents surface flaws or details, so we can add depth to the surface without actually having to model more polygons to do so. Typical, it's normal mapping. You're probably already aware of that. So now we come in here, we're going to go in, we're going to grab that texture I just showed you, so crate, and we'll just wire that to the color channel, and you'll see, boom, now it's being drawn. Ta-da! And now let's go over here into the world for a setting, and we're going to turn on ambient occlusion. Just going to show things up a little bit better. It's going to have kind of a universal lighting effect. So there is our surface, nicely textured and done. Now you'll notice we also have a normal map input right here. So we can also pass in normal information. So let's do that as well. So we'll move our output over a little bit more. So we got a little bit more room. Move this guy up. So now we're just going to go ahead and add another node. It's a texture, an image texture. And we're going to load in our normal map. Now, as you see, I've got a yellow out to a yellow, but you obviously don't want to hook this up. So look at what happens when we do. So we just overrode the color information coming from our original image texture. Obviously not what we want to do. And another key thing that this is showing is you can only have one input. So this one will overwrite that input. So if you need to get away from that, what you need to use is mixers. For example, let's see, that's just shader, mix shader, so, and then you could have two shaders feeding into it. Now I'm not dealing with shaders in this case, it's beyond what we want to use, but you can use mix for, there's also one for mixing RGB values, which is probably what we would have, actually that's what we would have wanted there. So that's under color. So see, like you see, and again the color coding. So you got your yellow input, so we can bring in our yellow from our texture map, yellow from our normal map, and our output. And what we've done there is basically mixed the colors from our normal map and our texture map together for the input. And obviously that is not what we want to do in this case, but I just wanted to show you how the mixing works. So let's go back to what we do want to do. So we have this color value, but instead we needed to export a vector for our normal. So we go ahead, back to nodes, add, and go to vector, and we go to normal map, like so. So you see normal map takes the input of a color and the output of a vector. So go color to the color channel, like so. You can select this guy and pick the UV map that I made earlier. You don't have to. And then vector to normal. And now if we look at it really closely, so connected, you just get more surface level detail in the overall shape. And we can also change the strength of it here, like so the amount that it's being applied, or weakness, a little bit more, etc. So that is a very typical shader graph approach to creating a scene. And then your end result, when you go ahead and you're going to do your render, now I'm not going to cover things in too much detail because this is one of those things you're going to want to jump in there and play around a whole lot. You can create hyper complex graphs. Let's at least look at the nodes quickly. So you'll see here we've got, you can group things together, but you've got the ability to define a script that outputs whatever results you want. You can convert between different values. You can, we saw vectors here, for example, turning your color into a normal map. You can mix up color values. You've got various texturing options. We already used image, but you could also have environmental textures, sky textures, noise textures, etc. You've got your outputs, which we saw. There's the two options, material and otherwise. And then another key one, oh, and then there's all your various shaders. So instead of, for example, this diffuse shader or standard color shader, if we want to use a different shading model, we could easily add, let's say we come in here and go with oops, didn't want that. I want tune shader, tune. I don't know why these aren't in alphabetical order, but they aren't. So same deal though. Hook up your input, hook up your normal, hook up your output. And now it's using a tune shader. Now tune shader mostly can come down to how it deals with the texture you're dealing with. It just creates that flatter anime style in the end. So without a side-by-side, you're not going to really see what the end result of that was. Now another major thing here though is your input. You've got all kinds of information that can be passed into your shader from Blender itself. So for example, texture coordinate information, attributes, RGB values, layer weights, geometry information, wireframe information, object information, particle info, camera details, the UV map details, etc. So this is sort of like when you're dealing with shader programming. All the various sort of inputs that are being passed into the shader, well, these are all the ones that are being passed in here that we can optionally use. Now you notice in this case, we're not using any at all. And one that's kind of hidden away that's very useful is under object info. If you look really close, it's got a 0 to 1 value called a random. So if you need a random number generator, so for example, if you were randomly creating a color between, black and white or whatever, you could use this as the seed value for that. So that's the options there. But the complexity of this is all down to what you do. This will get you back to the normal, look at me, I just created a texture mapped, normal mapped object like you had from before. And you'll notice here when we go into materials, it's slowly populating it with the values as we add them. So we've now got our tune surface settings. That color map channel came from an image texture. We can change the values. So all the values we can change in here, we can also change over here. And since we added those two image textures, you'll also see that they're available over here under the normal textures tab as well. But for the most part, you can do 100% of your editing here in this graph, and you could get rid of this completely if you wished. So now let's talk about the two final things of importance. When you're dealing with cycles as opposed to the built-in renderer, there's two things, especially if you're working with sprites, that you're going to want to know: how to do a background and how to turn the background off. Now if you want to do a background in your worlds, like if you want to have a sky texture or an environment map or something, you come into the world settings right here and you can set it here. So you can have a background texture applied. We can come in here and go create it as an environmental texture, or say as an image texture, and then we could have come in, if I had one, we come in here and add, say, the clouds or the background map or however we wanted to do. So this is where you define your background image if you need one per se. Now, let's say I'm rendering though, and I want to not have it. So there used to be where you went in, you used to go under the very unintuitive sky and pull it down and change it to transparent. Now what you do is you go to film and change it to transparent, and it gets rid of the background completely. Although what you'll notice here is the background color is having an influence on the things in the shade, in the scene, and obviously that can be controlled via the strength. We can basically turn the strength down, or we can make the background very, very effective. So those are your key things. Now, this example I've made for you, it's not going to be incredibly obvious, but another thing that's of critical importance when rendering with cycles is samples. Now this particular example, it's just a raw texture map. There's not a lot of calculations going on. There's not a lot of reflection or glossiness or anything being done. But when you do a render with cycles and you've got a lot of light interacting with the scene, or you've got a glossy material, etc., you'll get a lot of dots. It'll look like crap. And what you need to do to change that is up the number of samples. And again, this example isn't showing it very well, but you can jack it up in preview. I don't even think this will do anything at all in this example, other than slow things down. But if there was glossiness, you'll know what I mean. There'll be a whole bunch of little dots in your scene, and when you want to get rid of them, you need to jack up the number of samples used. And it could be, if you have two chromatic or two highly translucent surfaces beside each other, you may have to jack this guy up to 2000, 3000 kind of thing, or switch it down to branch path tracing and define each channel independently. I generally just go with this guy and jack this guy up really high. But another thing you'll notice though is once you've done that, here is a render of a very simple scene. And because there's so many light samples being shot out, it's not fast by any definition of the word. And I'm not on a slow laptop by any means. So as you jack up the samples, expect much, much better results. but also expect a much longer wait overall. So anyways, that's a quick crash course in cycles. I'm not going to get into a lot more detail. I think I've given you enough that if you're used to the traditional render, you should now be able to figure out at least the basics of how to start working with cycles. And again, if you're just exporting materials out, or you're just exporting textured models or animated models out of Blender, you don't need any of this at all. This is only for rendering. But your rendering results using cycles can be so much nicer than the rendering results using the built-in renderer. So it's definitely, if you're making sprites or single frame images or animations, you should definitely take the time to learn cycles. It's a much better, if extremely slow, solution for rendering. So that was it. Hope you enjoyed. See y'all later. Bye.